This is PreCalculus 12, Chapter 6.3. We're going to be looking at the radian measure some more. Recall that the degrees equals 180 degrees times the radian measure divided by pi, and the radian measure is pi times the degree measure divided by 180 degrees. So let's try to convert 1 degree. This is pi times 1 degree over 180 degrees. Cancel out the degrees. And we get pi over 180 radians. Let's try to convert 2 degrees. So we have negative 3 pi radians over 2 times 180 degrees over pi radians. And the radians cancel out and the pi's cancel out. 180 divided by 2 is 90 times negative 3 is negative 270 degrees. Okay, some more quick exercise. Find all coterminal angles with pi over 4. This is already a principal angle. So pi over 4 plus 2 pi n. N being in the set of integers. So the equivalent for the degrees was 360 degrees times n. And 2 pi radians is once around. So we're doing exactly the same thing. Try to find all coterminal angles to 5 pi over 4. Again, this is a principal angle because it's less than 2 pi. So we just go 5 pi over 4 plus 2 pi n from the set of integers. So, as some of my students like to call this is the wheel of death. We have 0 to 360 degrees. We also have 0 to 2 pi. And then we have our cosine and sine. This is cosine is our x, sine is our y. Remember, it's Sir, sy over r, Kixer, cx over r. But notice the symmetry. We have a half, a half, a half, a half. We have root 3 over 2, root 3 over 2, root 3 over 2, root 3 over 2. However, there's a negative sign here for the cosine, negative sign here for the cosine, a negative sign here for sine, and a negative sign here for sine. And when I'm saying sine for sine, I mean sine for sine. Okay, and we see 1 over root 2, negative 1 over 2, negative 1 over root 2, 1 over root 2, 1 over root 2, 1 over root 2, negative 1 over root 2, negative 1 over root 2. So there's symmetry here. You don't have to memorize all of these. All you have to do is memorize the first quadrant. That's why we came up with reference angles. And there's a reference angle in each quadrant. And there's special angles. These special angles have these special values. So 0 has 1 for cosine and 0 for sine. 30 degrees, or pi over 6, has root 3 over 2 for cosine and 1 over 2 for sine. 45 degrees, or pi over 4, has 1 over root 2 for cosine, 1 over root 2 for sine. At 60 degrees, or pi over 3 radians, we have 1/2 for cosine and root 3 over 2 for sine. And at 90 degrees, or pi over 2 radians, we have 0 for cosine and 1 for sine. Again, we don't have that much to memorize. 30 degrees and 60 degrees are complementary angles. So all we're doing is reversing sine and cosine for 30 and 60. So you have really 1 and 0, root 3 over 2, 1 over 2, and 1 over root 2. And those are the only ratios you have to remember. And you just have to remember that we need to flip them for the complementary, and then we change the sign for the other quadrants. So spend some time just memorizing a few numbers here, not too many. So here's how we use our knowledge. Determine the exact trig ratios of the angles. Use the modulus function. This is not the same as remainder. They differ when using negative numbers. An analogy is using a clock. When we subtract 3 hours from 1 o'clock, we don't get negative 2 o'clock. We get 10 o'clock. So, same thing here. So, if we're doing a modulus operation, we just get 4 over 3 pi. If you didn't want to use the modulus function, you would have to go 8 pi over 3 minus 2 pi, which is the same as minus 8 pi over 3, minus 6 pi over 3. Sorry, this should be plus. We're in the negatives. We want to add. And then we get minus 2 pi over 3. It's still not a principal angle, so we have to go minus 2 pi over 3 plus another 6 pi over 3. And then we get 4 pi over 3, which is what we have here. Graphically, it looks like this. Negative 8 pi over 3 is a clockwise rotation, once around and there. And 4 pi over 3 is in this direction. And we have a coterminal angle. So, what happens if we have an extremely large number? You don't want to just keep subtracting 6 pi over 3, 6 pi over 3, 6 pi over 3 until you get the principal angle. You want to use the mod function. This gives us 4 pi over 3. You could do this by using a simple calculator. And what we need to do is 148 divided by 3. And then we have to divide it by 2 because we're modding it with 2. So that means it's 24 times around with a remainder of 0.6666, which is 2/3. We need to multiply this by 2 because we were dividing by 2. And this is 4 pi over 3. We took the pi out of our calculation, and we need to put it back. So just again, we have 24 and 2/3. We lop off the 24. We multiply the 2/3 by 2, and we get that. So you can keep on doing these complex calculations, or you can just program your calculator. There's a separate video on how to program your calculator, but we'll just go ahead and use the program. Okay, so to run the program, you just press program, and then we execute the mod function, and we press that, enter, and we enter our number. So enter this without the pi. So we'll do the negative 8 over 3 example first, and you can just enter negative 8 over 3. And then we enter 2. We don't need to enter the pi because we're assuming that we're going to put that back in. And we get 1.3, and we can go to the math frac function, and that turns it into a fraction, and we have 4 over 3 pi. Let's try this again. Program, execute mod, and now we'll enter the 148 divided by 3. And again, we're just leaving out pi for both of these, so just 2. And we get 1.33 again. And remember I said mod is different from remainder. You don't need the remainder program. I'm just using it for demonstration. So if we did a positive value, it's not a problem. 148 divided by 3. and then we're modding it with 2, and we get the same thing. So it's positive is fine, but let's enter the program again, and we're going to do the -8 divided by 3, and then the 2, and we get -0.666. So like I said, like a clock, we don't want negative values, and we would have to add 2 to this to get our 1.33. Okay, so that's a simple program to use. Doesn't take very long to program it in. So back to our original question. 4 pi over 3. We want to find the exact trig ratios for the angles. 4 pi over 3 is in quadrant 3. The reference angle is pi over 3. So we go to our chart. Pi over 3. We see that cosine is a half, sine is √3 over 2. And again, if you're starting out and you don't remember, you can look at 4 pi over 3 over here. You get negative a half, negative √3 over 2. So sine, we have negative √3 over 2. Cosine, negative 1/2. Tangent, we have √3. Tangent is positive in quadrant 3. All students take calculus, so tangent is positive, it must mean sine and cosine are negative. And for the reciprocal functions, -2 over √3, -2, and 1 over √3. Okay, we can use our modulus function with degrees as well. Let's take a look at that. Let's take a look at this on the Casio this time. On the Casio, you need to go to Menu and Program, and then you execute the program. So we have 2010, and we want to mod this with 360, and we get 210 degrees. And let's execute it again. We have -570, and we want to mod it with 360, and we get 150 degrees. Okay, so just to double check our answers to make sure that the program's working, -570. I know I need to add more than 360, so I'll just go ahead and add 720. And we do that calculation and we see that it is indeed 150 degrees. Okay, another type of problem to solve. Area of a sector. So we have our radian measure. The full circle is 2 pi. So the radian measure divided by 2 pi is the fraction of the circle. And an area of a circle is pi r squared. So this is not a difficult formula to remember because you already should know pi r squared. And you should know that taking the radian measure, dividing by the full circle, 2 pi, will give us a fraction of a circle. So we can go ahead and simplify this if you want to simplify for your formula sheet. We can cancel out the pi's, and then we get area equals theta over 2 r squared. Now, if you're really married to degrees, we can do the similar formula for degrees. We take our angle, we divide it by 360 degrees, but we still have to multiply by pi r squared. We don't get that extra simplification of eliminating pi. Okay, so let's go ahead and calculate the area of this sector. So we have area equals 2 pi over 3 over 2 pi r squared. Cancel, 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 cancel. So we have pi r squared over 3. So we weren't given the radius, so we just leave the radius as r. If we had the radius, we could just plug it in, and then we would be expected to add the units. And it should be units squared because it's area. Okay, a harder problem is the backwards problem to find the radius. And we can use algebra on these formulas to figure out how to calculate r. So, because we're multiplying by a fraction, we can just multiply by the reciprocal. So 2 over theta a equals r squared. So r equals the square root of 2a over theta. And we don't need to do plus or minus because the radius is a length and a length should be positive. And over here for degrees, we have to multiply by the reciprocal, and we can add this to the denominator. So r squared equals 360 degrees a over theta pi. So r equals the square root 360 degrees a over theta pi. And I mentioned this last time. Recall, revolution means once around. So we have 1 revolution equals 2 pi radians. 1 revolution equals 360 degrees. Revolution also means 1 rotation. Angular velocity is usually radians over time, but still must show units. And be careful with formulas if it's using revolutions per unit of time or degrees per unit of time. Do the appropriate conversions. Let's look at an example. Using angular velocity, how far does a 30 centimeter diameter wheel travel in 25 seconds when rotating at 100 RPMs? That means revolutions or rotations per minute. Some of our information is indirect. We're given diameter, so the radius is 30 centimeters divided by 2. That's 15 centimeters. So the angular rotation, we denote this with V subscript A. So 100 revolutions per minute. We have seconds here, so we should convert this to seconds. So we want to multiply by 1 minute over 60 seconds. And we need to multiply this by 2 pi radians per revolution. So let's cancel to make sure the units are correct. Revolution, revolution, minute, minute. Now we have radians per second. So we have 100 times 2 pi, so that's 200 pi over 60 seconds, radians per second. We can simplify this again. We can cancel out a 0. And a common factor between 20 and 60 is 2. So we have 10 over 3 pi radians per second. Okay, how does this help us? You need a formula. D equals angular velocity times radius times time. And this must be in radians. And we have that. First of all, T equals 25 seconds. D equals 10 pi over 3 radians per second times our radius, that's 15 centimeters, times our time, which is 25 seconds. And let's go ahead and cancel some units. And really, radians is a unitless unit, so we can just cancel it out. It means a ratio, and a ratio is just a number. So we actually have centimeters left over, which is good for distance. 15 divided by 3 is 5. So 5 times 25 is 125. 125 times 10 is 1250 centimeters. And sorry, there's a pi in here. Okay, so if you were looking for an exact value, you would leave it like that. If you were asked to give a decimal value, we would convert that, and this would be 3.93 meters. So this would give us an answer in the thousands, but let's convert it to meters because meters makes more sense. And that completes this lesson.